Okay, I mentioned earlier that there's a couple of different ways of computing this sum of squared deviations, or this SS, or sum of squares. The one way is that the one we've learned in our text, and it's called the deviational formula, where you take the sum of each deviation score, and by deviation score I mean you take each raw score, subtract the mean from it, square it, and then you add those squared deviations, and that gives you the sum of squared. So I'm going to show you that formula just so that you gets reinforced what we've learned in the book, and then I'm going to show you in red another way of calculating the sum of squared deviations. You'll get the same answer regardless of which way you use. The advantage of this, what they call the computational formula, is that it avoids using decimals, especially when you're dealing with decimal points two digits out. It makes the calculation to get the deviation from a mean that is, let's say, 6.33. It's a little bit of a hassle. So anyway, let me just show you how you do this both ways so that you'll be convinced that you come up with the same answer. So here I have the raw scores. That's this column X. And I have 3 scores, so N equals 3. 1, 2, 3. Here's the raw scores. There's a score of 1, score of 2, score of 3. If we sum those x's, we get 1 plus 2 plus 3 equals 6. And to get the mean equals the sum of x over n equals 6 over 3 equals 2. So this second column is asking us to get the deviation. So it's going to be 1 minus the mean of 2. This is 2 minus the mean of 2. And 3 minus the mean of 2. And this gives us a deviation score of -1, 0, plus 1. Then we square that, and we get -1 times -1 is 1, 0 times 0 is 0, +1 times +1 is 1. If we sum those square deviations, one plus 1 equals 2. We get the sum of square deviations equals 2. So now we're going to do that very same problem using the computational formula. And it looks this way. Here's our 3 scores, a score of 1, score of 2, score of 3. As before, we get the sum of x equals 1 plus 2 plus 3 equals 6. We get the mean, same thing as before, equals 2. Now our formula is this. The sum of squares equals sum of x squared minus the sum of x squared divided by n. So let's see what this is. Sum of x squared. Well, we have the sum of x. We don't have the sum of x squared, so let's get that. We have another column here, x squared, so 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. We add those, 1 plus 4 is 5, plus 9 is 14. So the sum of x squared equals 14. I'm going to put this right here. The sum of x squared, we took each x and squared it. 14 minus the sum of x. Well, here we have the sum of x. That's 6. We square it, so 6 times 6 equals 36 divided by n. Well, what's n? Well, we have 3 scores, so n equals 3. So the sum of squared is 14 minus 12 equals 2. Yes! 2 equals 2. So either way, you'll come up with the same answer, I promise you, regardless of the method you use, either the definitional formula that we used in the book or this computational formula for the sum of squares. Okay, I hope this is helpful and I hope it makes sense.